Everything you see in your house, from the plastic in your kitchen utensils, to the foam in your mattress, from the rubber in your bicycle tires, to the asphalt itself. All of this can be tracked back to oil processing. Oil processing is where crude oil is separated in its smaller components by physical or chemical processes.
Crude oil is a mixture of hydrocarbons, which are carbon atoms bonded with hydrogen atoms. Since the carbon atom is versatile, it forms countless hydrocarbons with different shapes and forms. The number of carbons in the chain affects its weight and state in different temperatures. For instance, the smallest hydrocarbon is methane, composed by a single carbon atom that is a gas in room temperature. Hexane, a hydrocarbon with 6 carbons, is liquid in the same temperature. And asphalt, which has more than 70 atoms of carbon, is solid in room temperature. This is the main aspect that influences the distillation process. The distillation is the heart of an oil refinery, and it's where the process begins. The crude oil is heated in a boiler, making the mixture of hydrocarbons break apart, and then it is loaded in a big column. The column is divided in several stages where the products are removed. The light elements, which are gases that have 1 to 4 carbons, like methane and naphthalene, go to the top of the column. The elements that have between 5 and 70 carbons are liquids, like gasoline and kerosene, go to the middle of the column. In the bottom of the column is where the solids stay, like tar, coke, and asphalt. Here, a chemical engineer can work as a process engineer, providing technical guidance in operation of the equipment, as a project engineer who designs the size and improvements to the columns, or as a process control engineer dealing with optimization and troubleshooting. After the removal of the products, they pass through different kinds of units to receive proper treatment. One treatment is composed by breaking the large hydrocarbons, unify the small ones, or rearrange the undesirable into a usable product. In addition to those treatments that change the shape of the molecule, there are treatments to purify the product. Water, sulfur, nitrogen, and another uncountable number of elements are present in the hydrocarbon mixture, and they need to be removed. A chemical engineer is required here to design the equipment and control all the treatment processes in order to obtain the required product in the right quantities and standards. Finally, when the products are purified and in the right standards, they are distributed to other industries or to the market. Another role of the chemical engineer is in the supply chain optimization, negotiating with commercial traders on pricing and dealing with logistics agencies.